Okay, so 3U factoring review. We're going to do numbers 21 to 25. So 21 is going to look like this. It's x to the power of 4 minus 3x squared minus 4. So a little trickier of a question. So this is this can actually be factored as a simple trinomial with, again, just one trick. Okay, so what we're going to do here is we're going to let m represent x squared. Okay, and so what we're going to do is this equation is going to turn into x to the power of 4 is going to turn into, in relation to m squared, minus, we already know x squared is m, and minus 4. That looks like something we can factor now, right? So this is a simple trinomial. Okay, and so we're just going to factor it by finding two factors that multiply to -4 and add to -3. So those two numbers are going to be -4 and 1. And so we're going to write m minus 4, m minus 4 times m minus 1, plus 1, sorry. And then this question, we're not quite done because we've got to make the substitution of m back as x squared. Okay, and so we're going to see in the next line, we're just going to go x squared minus 4, x squared plus 1. Okay, so this is a little trick to allow us to tackle questions that we maybe haven't seen before, or don't necessarily look like they follow the normal rules. But that simple substitution there turned that into a simple trinomial. Now you'll notice with 21 that this is not the answer on the page. That's because after we make our substitution of m back, we still have this piece here that we can tackle, right? That's a difference of squares. So I'm gonna tackle that accordingly. Okay, and so we're just gonna go x2 times x2, opposite signs, and x squared plus 1. That should be your answer there. Okay, so number 22, that's a tough question, 21. Okay, 22, 10x squared plus 7x plus 1. Okay, this is just a complex trinomial with the big a coefficient. Okay, and so we're just going to find two numbers that multiply to 10 and add to 7. Okay, those two numbers sound like 5 and 2. Because it's a complex trinomial, we're going to break that middle term up to be 5x plus 2x plus 1 and 10x squared plus. Okay, and so factor by grouping. So look what's common across the first two terms. Well, it looks like I remove a 5x, and what happens when I remove the 5x? I'm going to be left with 2x plus 1, and plus 1 on the other side, because I can remove a 1, divide by 1, and we're going to be left with 2x plus 1 there. Now, across the two terms, we're going to have this shared 2x plus 1, so we're going to factor it out and be left with 5x plus 1 for 22, and that should be your answer. Okay, 23. 23 is 4x to the power of 6 minus y to the power of 6. This, again, looks a little different. Different variables, though, so the substitution piece isn't going to work. So what we're going to end up finding here, just is straightforward difference of squares. Anytime you see two terms and a subtraction sign in the middle, I'd be suspicious of the fact of whether or not it's difference of squares. Okay, so that means I can square root the first, square root the last, and I should be left with 2. When I square root x to the power of 6, I'm going to get x cubed. And when I square root y to the power of 6, it's going to be y cubed. You're going to write this twice because it's a difference of squares. Okay, and then they're going to have opposite signs, and that should be the answer on your page. Okay, question 24. We're going to have x squared plus 4x minus 21. That's just a run-of-the-mill simple trinomial. Okay, and so we're looking for two numbers that multiply to negative 21 and add to 4. Okay, so the two numbers that satisfy those conditions would be negative 3 and 7. Okay, and just simple trinomials are nice because as soon as you find those two factors, you just write the variable in front of the two factors you found, x minus 3, x plus 7. That would be your answer. Okay, one more question here. 25. 2x to the power of 4 minus 3x squared minus 2. So there's that little trick again. What you're noticing here, we're cutting the exponent in half. It behaves in a simple trinomial manner, or a trinomial manner, like a complex or simple trinomial manner. So the same thing could be said for something like 2x to the power of 6 minus 3x to the power of 4 minus some number. Okay, so we're going to make that little substitution trick again. And it could be anything, whatever letter you want, and represent x squared again. So we're going to rewrite the question. 2m squared, right? Because x to the power of 4, if I rewrote it as m, it would have to be m squared, minus 3m minus 2. And so now I can factor this as a complex trinomial. Is two numbers that multiply to negative 4, add to negative 3. Sounds like negative 4 and positive 1. Because it's a complex trinomial, we're going to split that middle term up. Okay, and now we can just factor by grouping and be done with the question. So 2m is what's in common across the first two terms. We're going to be left with m minus 2. Plus 1 again, I can divide the other half by 1, and we're going to be left with m minus 2. And then factor the m minus 2 out and write what's left. 2m plus 1. That should be your answer on your page. And that's it for this video.